I would like to ask Seth and David to join us in the speaker circle. So if you can just click on, very good. And Rodrigo, if you click on the camera button.
Yeah, it's not coming up. It's not coming up. Sorry.
No worries. We'll make it work either one way or another. While we're doing that, though, I can I'll share my screen just to keep us in context. So we've got the co-founder and head of product at Modzy, Seth Clark, who's joining us, and also David Purón, who's the CEO and co-founder of Barbara. As we did with the previous panelists, if you would like to just take 30 seconds to introduce yourself to the audience and a little bit about your experience with AI and ML, we can start with you, Seth.
Oh, great. Bart, thanks again for having us. So my name's Seth Clark. I have a background in actually computational fluid dynamics. I wanted to study yacht design after grad school, and right as I was looking for jobs, Lehman Brothers collapsed. So I had to make a tack to add a sailing pun to the intro, and ended up finding this space of machine learning and data science using math to solve different kinds of problems. And now at Modzy, one of the things we focus on doing is helping our customers run their machine learning models on basically any device anywhere in the world.
All right, fantastic. Thank you very much. And David, how about yourself?
Yeah, hi everybody, how are you? So I'm David Purón, I'm co-founder and CEO of Barbara. For lack of a better word, I'm a serial entrepreneur, so this is my fifth company. I come from the smartphone world, so I'm an expert in cybersecurity and firmware. And at Barbara, we started in 2016 building an edge computing platform, so a distributed computing platform. And if you think in many infrastructures, after you build the infrastructure, you need the use case. And I think the use case for edge computing is basically AI. So in Barbara, we started computing any type of application back in 2017, 2019. But in the last 3 years, we've put a lot of focus on being able to run machine learning models, real-time machine learning models in edge computing, because as Gartner said, this makes a lot of sense and is going to transform the industry.
Very good. With that in mind, David, what industries are the ripest, the most mature when it comes to edge? What are the industries that are really catching your attention, where you see this is adding significant business value and cannot be overlooked?
Well, when you think in edge, there are a few drivers that can drive computation to the edge. First one is privacy, and the previous speakers were bringing like a really good examples of when data privacy matters, like for example, the health industry, right? You cannot put the patient data out of certain boundaries, so then edge makes a lot of sense. So privacy is one driver. The other driver is autonomy. So there are industries, they cannot afford any failure, like critical industries like energy or water or manufacturing. If a model that is running fails for example, a network problem or something, that can be a huge loss for them, right? So critical industries with critical processes, they need to run models or real-time models at the edge. They cannot basically just rely on network connectivity. And last but not least, latency. And I think we're going to be talking in this panel a lot about latency. So in some models and some inferences, you need both speed on reaction, but also kind of deterministic time, right, for doing the inference. And then again, you cannot rely on sending data to the cloud. So in industries like, as I said, like energy utilities, water, manufacturing, healthcare, all these industrial players, when they want to really bring value by bringing machine learning into their operations, they are getting a lot of benefits on bringing their models and their inferences to the edge.
Yeah.
Right. And Seth, in your case, what kind of use case, or examples could you give that require real-time edge, and AI-enabled insights?
I think about it in a lot of the same terms. But I kind of break it down into 3 big buckets where near zero latency AI actually is kind of a must. one are in applications where decision-making times just have to be made within milliseconds. And I think the best example of that would be something like an autonomous vehicle. The amount of time available to take an insight from a predictive model and inference, a detection, and translate that into an action taken on that device, on that system, has got to be really, really quick for safety purposes. So I think, autonomous vehicles maybe being the quintessential example for near zero latency. The second example that I like to think about is scenarios where you have really poor or intermittent network access. So if you have a remote oil field, there's a lot of scenarios and cases where there's either no network access at certain times of day because of cloud cover or weather events, or the bandwidth is so low, you couldn't possibly send every piece of sensor data. So instead, why don't you do the real-time processing on site and then send results, maybe specific insights that are generated. And then the third bucket is related to privacy. I think of it in terms of security. So situations where, for whatever reason, the data really needs to stay where it's located. We do a lot of work with government organizations, and the protection of PII and PHI is really important. So processing will happen on a physical device in a specific location where it can't be shared. We also work with some corporations that have manufacturing in parts of the world where there's concern that the government may try to access that data while it's being sent back and forth between different cloud regions. So they actually prefer to do on-site processing for that reason. So those are the big three. The fourth bonus is not really for low latency, but another big reason why you want to move a model to the data is when you have a lot of historical data in one location. Maybe you've got an old cloud provisioned environment. It's actually a heck of a lot cheaper and easier to send a new model over there than to move your petabytes of data back to some central hub.
Great. So once again, we see cases where it's a definite must, and then there are other cases where there may not be as much urgency. But like you said, in those, it's very, very clear. What about in your background experience, David, an example where you've seen this, where value has really been added?
Well, let's do one thing. Can we make a poll before? Can we use this feature of
yes.
blue and red? So can we, from the people who is in the audience, maybe the people who is working on batch inferences and batch processing can press the blue, and the people who is working on real-time inferences can press the red, to see how many people in the audience is working with real-time.
Let's take a look. Okay. We got an applause as well too. I'll always take applause.
No, so lots of real-time inferencing. That's great. That's great. So real life examples. I mean, we have a few of them, but one, for example, Seth was explaining some of the drivers, and one of the drivers is when you have to handle a lot of data, right, in the process. And we have a case, for example, working with a utility here, with an energy transport company here, Red Eléctrica in Spain, who is the company in charge of the high voltage network energy here in Spain. They are, one of the problems they have is when they have an energy cut on a problem, troubleshooting this was a nightmare, right? So they have an oscilloscope in the substation that is reading values, and they are building models that are reading these values and inferencing when a change or a problem is going to happen, and then in that specific time, they have to take a snapshot of the data so that the engineers can troubleshoot later, right? So this data streaming is bringing like 4,000 data points per second, including voltage and current. So you can imagine that, processing this in real time and making the exact snapshot when the model decides that there's going to be a problem is something that requires a lot of things to happen in terms of how you connect the data stream to the model, the APIs, the real-time inference, and so on. So this is a perfect example when Edge makes a lot of sense.
Very good. In order for these things to happen, though, right? We talked in the previous conversation towards the end about infrastructure. All right, so whether it's in the cloud, whether it's on-prem, Seth, in terms of deciding what kind of infrastructure or architecture, is going to be best, what are factors that people should be keeping in mind? What's your experience been like there?
Yeah, it's that's probably the hardest part about setting up an edge AI application, solving an edge AI use case, is basically figuring out where is the software going to run, and the division of labor, the separation of effort, where things go. One of the things that's challenging accounting for distributed computing is you now have, instead of a, many to one construct where you have a lot of clients connecting to one server, one API, you have a one to many construct where you have sort of one set of code, but you want to run it on 1,000 devices. It comes with its own unique challenges. One of the things that's important is you have to plan for things like network instability, building in resiliency so that things are going to keep working even if the network cuts out, or you can't, get a certain software release out to all of your devices. Having scenarios planned out for that is really important. Separating out the logic is one of the most important pieces, and I have a few recommendations I'll share later on. But generally speaking, there's a limited amount of hardware. You can only do so much in a true edge scenario. So being really thoughtful about what code needs to run at the edge versus what code needs to run kind of nearby. Maybe there's a small device that's attached to a camera that's doing the real-time bounding box calculation for, if someone's wearing a hard hat on a factory floor, and then those insights go to another system that has maybe more hardware, and that's being used to manage the automation of the facility. And then further on down the line, some of that information is going up to the cloud for future kind of historical analysis. You really have to think about what actually needs to be computed at each one of those pieces of hardware in order to build a system that's going to kind of have staying power and not collapse under a lot of load. And one of the last pieces that's really important factor is to think about and plan for the frequency at which you're going to have to make updates. Because unlike a lot of software, machine learning gets worse over time. And that's not something that normal application developers really have to think about. As long as the data contracts stay the same, your COBOL code can run the entire banking industry for 50 years. That's not the case for machine learning. And so we end up having to really plan out well in advance. How are we going to update new models? How are we going to update model versions? How are we going to, keep track of how those models are performing and being able to have this kind of virtuous cycle? And that includes, incorporating things like federated learning we heard in the last talk. It's more complicated to plan those things out in advance.
Like that, because it's something we see a lot, in terms of adoption of new technologies, talking about legacy systems. In this case, we're not really thinking there's going to be legacy systems, with the frequency with which these things are going to have to be updated. We got a question from the chat real quick. So from Arjun, how do you accurately monitor the model when it is running on thousands of edges? Either one, both, whoever wants to take it.
Go ahead.
Quick answer is just, you need to have a combination of on-device and remote monitoring. I think you kind of want to look at it from both ends. On-device monitoring can give you some basic info that's kind of like maybe low quality but quick time, and then you also want to be able to have access to that historical inference data to look at longer term trends. So I think, on-device as well as back in the central cloud are how I look at it.
Good, yeah. David, I'd like your feedback on this. And then also, David, can you respond to, we talked about infrastructure, but when deploying and monitoring models, what technologies are relevant? So answer this question, and then we can drive the conversation that way.
Yeah, well, very linked to what Seth was describing. I mean, it's important when we talk about edge to understand that the edge have different layers or different types of edges. So I like a sentence that says the edge has depth, right? So a regional data center can be edge. Then you can have server edge, which is edge in a server data room in your premises. And then you can have gateway edge, which is edge in this type of small gateways. And then you have device edge, which is computation and ML model running inside an embedded device that is doing other functions, right? So depending on what type of edges you're looking, maybe you have different type of technologies and different type of cases. So when you talk about what we call the thick edge, the edge that is relatively similar to the cloud, you have the Kubernetes stack and so on that you can use to for monitoring and for running stuff there. But when you go to smaller devices, to what we call the thin edge, which is the edge, the gateway edge or the device edge, you need to go for very specific built-in platforms like the one that we've built that allows the monitoring on very, very highly distributed endpoints, right? So you need to really go to very specialized tools. So it really depends on what is the level of edge where your model is bringing. If you're running the thick edge, you can go for the Kubernetes and some other similar to cloud stuff. But when you go to thin edge, you need to have like built-in agents and that are monitoring the models and the performance and aggregating this and sending this to a centralized platform that is doing the aggregation of all the data and the comparison with the remote monitoring.
Okay, great. David, also, we got a question from the audience. How are models deployed on different levels of the edge at the same time, on device, on premise, and regional data center?
So yeah, you have to integrate different tools for the different levels of edge, and those tools normally have APIs. Like using the APIs of, for example, the Barbara platform, you can deploy models regardless what is the hardware, the underlying hardware for gateway or edge device. So basically, you need to find tools that offer you an API that abstract you from the complexity that is behind. And Seth explained it perfectly. You can, with tools like Modzy or Barbara, you can deploy models on the underlying structure without needing to know exactly what is behind. And for that, you can use platform APIs.
Got it. Great. In terms of your experience, Seth, we're getting towards the end. So just want to be thinking about, next steps. What have you learned from the conversations that you've had with customers? What advice would you give to folks out there in terms of, the pain points you're seeing, the doubts, the gaps? What advice would you give to other people out there that are in the space that are going to be tackling these challenges in the future?
I think I'd start with a quote from Kunu from the great film Forgetting Sarah Marshall, which is just to do less. Don't over-engineer the solution. Do as little as you can, and you're much more likely to have success and also be prepared for scale. That can take a lot of different forms, but I think it means keeping models really lean and mean, focusing on a really specific subset of business functions that are kind of tied to the most high-value metrics in your organization are going to help make sure that you're getting real value out of there and moving quickly. IT and OT, I think collaboration between IT and OT is really important. As you have your kind of big picture strategic thinkers, leading up IT organizations. But at the end of the day, if they don't have a good understanding of what's actually happening within a specific facility or location, those details or end up what actually turn into improvements in performance, reductions in costs, increases in reductions in response times. All of that comes down to the real details. So IT and OT friendship, take your buddies out to lunch. There's really no replacement for that human connection. And then, two more thoughts. Separate and design your architecture to optimize for the specific pieces of hardware you have. So if you have a computer vision model and you only have one GPU, try to have just the computer vision model that can get the most power out of that on that GPU, and separate out all the other logic, all your application logic, all of your streaming, your MQTT feeds. Try and divide that out. And even within, let's say, the model itself, model pre-processing, inference, and post-processing can all also happen in separate locations. And breaking things down into the smallest component means you can get the most, bang for your buck performance-wise. And lastly, just plan for the recognition that there's both greenfield and brownfield systems, existing hardware that's just out there that you can take advantage of, and new stuff. You want a solution that can work on both of those, because replacing hardware is really time-consuming, expensive. They have long life cycles. The money's already been spent. So try not to build something that only requires the latest new, insert, ASIC chip of choice. Those are my recommendations.
Very, very good. And I like starting with the beginning of start with some, less is more, do less, build something that can be scaled out, keep IT and OT factors in mind. We talked about that when we we're engaging first before the event, and that can never be, I think, underestimated, the importance of making sure that these different groups are aligned before setting on that journey, because those decisions around what technologies are going to be used, like you said, the money's already been spent on the hardware. Great points to keep in mind. David, what about for you? What are things that, when speaking to customers that have come up time and time again, that you would share with others that are in the industry?
Yeah, I think the key thing is when you're building a model and a case, you think how this is going to be put in production. I mean, the thing that we find in a lot of customers is that when they are building the thing in the lab or in a very controlled environment, that's very easy. But when they want to take this into the real field, there's a lot of challenges, right? So challenges around security, data flows, privacy, scalability, latency. So I think following a little bit on what Seth was suggesting, I think data science and data engineers, and they really need to bring IT folks and OT folks into the discussion from the very beginning, because then when you go to the field, you find a lot of problems. And I read a statistic that saying that only like 10 or 15% of the real-time AI models end up in the real field because of challenges that they find that they didn't find in the laboratory, right? So I think this is something that needs analysis, not only from the data point of view, but also from the infrastructure point of view, how you build how you will connect the data in production with the models and so on. So I think it's all about collaboration. It's all about bringing the right skills and bringing the right team into a project, and not only focus on the model and the training, because that's just a small part of the equation.
Fantastic. Well, thank you both very much for your time today. As in the previous panel, we have our amazing artist, Angel, who's creating artistic depictions of what's being shared. So here we can see a brief snapshot of the different factors that were included in the conversation. I think, as with the previous panel, yeah, we can definitely give this a round of applause. I think, as with the previous panel, it's just very, very clear evidence that there's so much more to dig into. And that's why I'm very happy that what we're doing today is really only the beginning in terms of the conversations we can have around this topic. So thank you both very much.